As a complement to the last video, now what we're going to do is look at some samples of infinite limits. So we're just going to go down this grouping here. As I said, the left column is for you, the right column is for samples. So here, if we have 2b, which is the limit as x approaches infinity of 8 over 4 minus x squared, pretty simple there. All that's happening here is this denominator is getting really, really, really large, meaning 0 is our answer, and the denominator explodes. When I say large, I mean large in magnitude because that's obviously going towards a large negative number, but that doesn't matter. Okay. Next we have D, which is the limit as x approaches negative infinity of 3x to the third minus 25x squared minus 12x minus 17, right? Remember, all that matters is the first term, the controlling term there. And if you notice, doing a little sign analysis, I'm going to have negative infinity to the third, which is going to be negative infinity. Here, this is a numerator explodes. Even though there's no technical numerator, remember, everything can be seen to be as a numerator. If it's exploding towards infinity, or negative infinity, we want to be able to use that analysis. Next, F, the limit as x approaches infinity of 2x to the fifth plus 12x plus 5 all over 7x to the third plus 6. We're looking just once again at the leading terms here. We see power of 5, power of 3. This is going to go to positive infinity. Just to do a little quick sign analysis there. There you go, positive infinity. And once again, numerator explodes. We love our infinite limits. Infinite limits are so much fun because they are real quick. H, the limit as x approaches infinity of 2x plus 3 over 4x minus 5. Oh, look, same order. I'm going to put my thumb over it, and I'm going to use the thumb rule. And there we go, 2/4 or 1/2. And there I go, thumb rule. And that's, wow, thumb rule. And that is what I write. And then last, I have J, limit as x approaches infinity of 3 to the x minus 3 to the negative x over 3 to the x plus 3 to the negative x. Now this one's kind of interesting because remember, I can distribute the limit across both addition, multiplication, subtraction, and division. So we're going to do this in a particular sequence. The first thing I'm going to do here is I'm going to distribute it to each term. So then this is minus the limit as x approaches infinity of 3 to the negative x over the limit as x approaches infinity, 3 to the x, plus the limit as x approaches infinity to 3 to the negative x. So now when we look at this, what's going to happen here is 3 to the x, this would go to infinity, this would go to infinity. But these are going to the infinity at the same ratio as each other. Interesting. But we've got these other terms here. As 3 to the negative infinity, that's going to go, this term just goes to 0, right? 0, 0. Now if you look at it, if that term's 0 and that term's 0, what I've got here is the same expression over itself, and then I can just use my normal identity, and that's just equal to 1. So the ability to distribute limits is super important when you've got more complicated things, because sometimes some terms will go away, which will then lead to other simplifications. So there you go, some samples of some infinite limit problems.